So now what you go through to do, we're going to actually be, once you cut up your data, you're going to be fitting it in a certain way. You're going to be fitting the how much part of the data. You're going to be doing an equilibrium fit. Later in the class, we're going to be doing kinetic fits, but chapters 6 and 7 are all about kinetics, so we haven't talked about the math of that yet. And I could show you how to do it, but it's a lot to do and it wouldn't make any sense, and you wouldn't be writing about it until the end of the quarter. So lab 5, you're going to be taking the same data. So as you're going through and you're slicing up all your data, remember this counts double because it's going to count for lab 3 and lab 5. When you get the data all together, I'm going to compare it all. And one of our questions is, you know, there are several ways to fit the data kinetically. You'll be able to compare those different ways of fitting. The answers, by the way, are going to be, in terms of K values, they're going to be maybe up to an order of magnitude different depending on how you fit it. That sounds like a lot until you realize that K values are on the scale of, you know, their ratios of products to reactants. So we're talking log scales of variation there. So hopefully you'll have like 2 to 5-fold difference between the different methods, but sometimes you can have up to 10-fold difference. And that's actually just what people see, okay? We'll take the most reliable way of fitting the data that goes with all our other data, and that will be the data that we actually compare and we draw conclusions from and things like that. So the thing is, once you get the programs installed, when you type in BIA, you'll get 2 programs installed, actually. There are 2 folders, and you'll need to install both of these. BIAcore 3000 control software, which is, if you notice, it looks an awful lot like the program that you're running already. It is the program. It just won't be able to connect to the machine because you're not connected to a machine. BIA Evaluation is where you take the data and you actually cut it up. So the bottom one, the control software, is for looking at the data. The top software, the evaluation software, is for processing the data. So we're actually going to open up the evaluation software. And that's what we're going to be using today. There's a way to do it. For the lab report, I'm going to ask you to go into the control software and do some screenshots and look at some things, just like I'm going to ask you to look at the data that we used to make the chip to understand how we made the chip way back when. Which reminds me, I did not pull that data off. I need to remember to pull that data off the instrument so I can put it up on Canvas. That will be on Canvas soon. And you can actually, now that once you have the data set up, you can start to look at the lab report and look at the other things you're going to have to do, although it's not due for another 2 weeks now. Okay? But I do want you to understand that there's some things about the physical nature of BIAcore that are on this PDF. And I will post the video of what we're doing right here to be able to see what's going on. So the BIA control software looks exactly like what you're already doing, and you're familiar with now zooming in on that, you know, and it has all the report points and things like that. BIA evaluation here looks kind of different. Let me go ahead and go through all the steps that you need to do. I'm going to go through information and data here. And right here you have BIAcore zip file. By the way, let me just explain a few things about this before I move on. The zip file has all the data to today, and I was actually reading some Sharpie marks wrong originally. On our original data, and you'll see this work out today, a lot of our original data will have things like, it will say it's 100 micromolar or something like that. We don't have 100 micromolar samples. Our samples are all in the range 2 micromolar to 50 nanomolar. I was misreading nano as micro, okay? Just so you know, and that's actually I'll show you what that looks like. If we mislabeled it, I've caught up to myself and I figured it out. And so like for all the people who've collected data over this weekend and things like that, your nanos and micros are right. Just make sure that your micro should only be 1 or 2, and your nanos are going to be in the hundreds, maybe down to the 50s at the lowest. The other thing is, and this is just a little note about when you install the BIA evaluation, There's one thing you should do at the very beginning, and that's why I opened this up. I don't need to do this anymore, but you will need to do this because for some reason it's decided that you don't need the average function, mathematical function, in your program. So you have to actually grab it and put it into the program. This is how you do it. When you first have BIA Evaluation open, you actually are going to, before you have anything else open, you're going to go to Import Models. And the thing that you have to do is you have to find out where it put your stuff. So it puts it on the C drive, and I believe it puts it in the x86. Yeah, here we go, x86. Here's our two files, and you see here's BIA Eval down here. When you go to the BIA Eval folder, where it actually puts the home for all the files, it has more models.mdl, and it's looking for a model file. So you find this file, open it up, and right here you have one that says average. And so you click on Add, you click on Import, and it won't give you this message because you haven't done it before. Once you do that, you're ready to go ahead and process your data. So with all that in mind, let me go ahead and process it from the beginning. I'm just going to click on this, and I'm going to click on it and see what it does, you know. So that's kind of my modus operandi today. All right, so here we have it right here. What you can do is you can extract it all to a certain place. I've already extracted it to a particular place. Here's all your data organized by date. And this is why it's helpful to have both of the organizations to have the date in there, because the date doesn't always carry across on the file timestamp. But you can see right there, there's all our data that we've collected. If somehow it ended up saved in a different place and you need me to pull it off, just let me know. Okay. But we've collected a lot of data so far. I want to look at the first file right here, the 423. And the other thing is I'm thinking that we maybe should have two different files, or did we do it all that day? So we did it the first day, and we had people come back, and Angelina came back much later, and then, oh, Samuel, this is the one that you came back for your initial injections. I'm just trying to find those because that's what I wanted to show you how to do. So this is Samuel's initial injections. This is everyone else's initial injections. I'm going to show you how to do this, but what I want you to do is I want you to take your data from another, take your data from the data that you collected by yourself. So you don't have to do this again. So I'm not going to open it from there, but by the way, sometimes it might associate the file type with the control software rather than the evaluation software. There's two ways to get around that. If you can open as, which is a right click on most PCs, that will give you an open with this application. You can choose the BIA Eval application from that, or you can do what I'm doing right here, which is you open up BIA Evaluation, and then you open it up from within this. So now I'm going to go back to where I saved the files. Here's our nice little, there. I'm going to open up Samuel's first. No, I'm going to open up the other one first. So when you open it up, it asks you how you open it up. You want to open it up. And so I'm going to ask it to do curves and report point table. And then I'm really only interested in the subtracted data. You only look at the individual flow cells when you think there's something wrong, or when your professor asks you to do it for the lab report, okay? But for this right here, you're going to just select the subtracted data. You don't need the other data. You say, okay. And what it's done is it's done and it's put a data line, a red data line right here. And down here, in the background, it's put this report table. This report table has the time and your little notes that you put in. Remember how I said that those little notes were going to be really important? Well, this is why, because they're right here. And you can see each time, the most important thing is you have the time point, and then you have the notes that the little flag that you put down. And so we can see that we have all of these different things, and we have all these people coming together. We each did like different ASP injections, okay? And then we moved on to the lice injections. So the ASP injections go down. We did a bunch of blanks. Everyone did a blank, so we have a bunch of blanks to choose from. And it went on. We have an ASP injection there. And we finally decided to move on to lice 3 here a little bit before 10,000 seconds. So that's the area that we're going to be looking at. We need to take that. This tells us where our data points are, which is good because when you open up this, if I double click on this to open it, or actually if I double click on it, it tries to rename it. Actually what I want to do is I want to click on this plot overlay button. This shows you the data. But of course it's zoomed out because it's not very smart when it comes to that stuff. So you need to do your usual make a little stripe and zoom in. And now when we zoom in a couple times, you can start to see, oh, there's our data. So I know that my 10,000 and on is going to be my ASP data. All of this is going to be well, actually we started with the ASP and then we moved on to lice 3. Like this is lice 3, right? So let's do the ASP and let's fit it all together. We can take those and we can fit them together as a single piece of data that shows what happens when you put multiple concentrations over the surface. So the way I'm going to do that is I'm just going to start from the beginning. At time 412, we have a blank. So I'm going to zoom in kind of on that. And I'm going to look for my blank. Okay, there it is. I can see my blank sort of jumping up a little bit right there. Now actually, the one thing I'm going to do is I'm actually not going to take this blank because this blank still has a very sloping baseline. You see our baseline calms down a lot after the first 600 seconds or so. That often happens when you're taking a chip out of hibernation. So I'm actually not going to take this blank one. I'm going to move on to the next one, which is going to be 912. It's a 800 micromolar ASP. And I can see right there. The one thing is it's kind of hard to see sometimes when you have a lot going on, okay? So we have the injection. You see the shark fin. And then you see the wash. And then you see right here we tried to do a regenerate. And it brought it pretty much back down to the original baseline. So I actually want to select that. Now the really important thing is when I'm selecting data, I'm going to select it to cut it. If I'm going to cut the data out, I want to right select. And you see that I get these little black boxes around it. That's like the cut and paste. I can resize the line. And I right select, scan over, and now I have the data that I want, and I'm going to just Control X. And you see it zoomed out, because it always zooms out when you ever give it an excuse to. But now, it's missing. Okay, we've cut it and put it in the clipboard. And now I'm going to Control V. I'm going to Control V it back in, and it says, okay, do you want me to put it in the original position, or do you want me to put it at a specified position? I don't want it back in the exact same place. I want it close to the origin. So what I'm going to do is I'm going to say specified x and y at x equals 0, y equals 0. And it's also, this is important, click that you want it in a new color so that all your colors aren't the same red. I'm going to say OK, and there it did. You know, if I zoom in on this, there's my little purple line. It's what I just had. And I can see that I have this regeneration. And I can keep that regeneration around if I want, or if I'm like, oh, I don't really need that regeneration. I can tell that it did what it did. I can right-click, select, and Control X this out as well. Be a little bit careful when you do this, though, because I'm not sure in this situation if it would or wouldn't also cut out the data that's above it. I don't think there's any data above it, so I think it's okay. But just beware that strange things like that can happen. So that is our 800. Oh, and we need to do one more thing about that. We need to remember what it is. So when I double-click on it, When you double click on the curve, it doesn't draw the curve, it gives you the chance to rename the curve. It's like a file in Windows Explorer or something like that. And so I want to say 800 nanomolar, and this is ASP. This is mostly a placeholder. I can figure out everything else from the context of this particular file. And now if I go back to my project window right here, I've got my magenta line is named 800 nanomolar ASP, and there it is. Now it's just a matter of finding my other ones and doing more of those. Okay, so the next one is I have another blank at 1889. So I'm going, and I always do this, I double click on it and then ask me to rename it. Now I'm going to actually draw it, and it was at 1889, right? So I'm going to sort of zoom in on that part. The one thing you want to make sure you don't do is you want to make sure that you select it. So 1889 is going to start around here. And it's actually interesting. I need to zoom in exactly to 1889. Something a little bit weird happened with this blank, but I'm going to go ahead and use it. 1889, well actually I want to zoom in a little bit more. I want to see where 1889 is relative to this. See, 1889 is here, but I think that I can draw, well basically I can go ahead and take this and decide later. If we take multiple blanks, we can later decide that one of them isn't a good blank. And the one thing that's hard about blanks is finding out where they end, okay? The one thing to remember about the blanks, though, is that you did your 40 microliters per minute, and then you do a 60 microliter injection, 180-second wait. So if I look right here, I can see that there's sort of the, this is sort of the association phase, and then it has sort of a dissociation phase right there. And the one thing that you can always look for is the little wash signature, you know? Right there, this is what's doing wash, and then it got back to baseline, and then we did our next injection. So I will do that. Control X, and I think I have multiple plot windows open, so I'm going to end up closing one of those. But Control X, Control V, specified X and Y, 0, 0, new color, okay. And there we have it. Now the one thing I want to do is I think I accidentally opened up two windows. Yeah, you see I have an old window. It gave me that error because I had the old window. One window had the magenta line, one window had the new green line. So now I'm just going to close both of those, and but now I'm going to rename my green line. I'm going to rename it blank. Maybe I want to rename it blank 1800S just to sort of remind myself which one it is, because I have a few questions over what that little divot was. If that divot is in the data, then we probably should select another blank. If it's not in the data, then we're fine. Okay. So, and you'll get to see me do this every single time where I accidentally rename instead of actually going into it. All right, let's see the next one. 400 microliters, this would be 400 nanomolar ASP, 60 microliters. All right, so let's go to, that's at time 2324. So 2324 is 400, so we're going to zoom in here. And once you're confident that you can see it, this is kind of helpful because it'll show you how to deal with the possibility of having big bubbles like that. Make sure that you select all the way through to the end of the wash, the little wash feature right there. Control X, Control V, new color, and double click on it. We're going to call it 400 nanomolar ASP. Now, I'm going to go ahead and edit it because I want to go ahead and take out those air bubbles. You have to use your judgment over whether the air bubbles are changing the underlying curve of the data or not. You know, if worst comes to worst, it's just a data point we can't use. But a lot of times there are data points that you can use. But the thing that you need to do if you're going to be cutting data out, you need to close the project window. You need to open it up in its own window with just the blue thing by itself. Now these have a very big refractive index. because air has a very different refractive index than water. And so we can sort of see, you know, it looks like this is good data. And so what I'm going to do is I'm going to, again, right-click select, and I'm going to go through to the end of the data. I'm just going to Control X. Now once it's gone, it's gone. I want to undo that. This doesn't have very good undo functions. Sometimes you can find it. But once I get a few more paces removed from this, if I want to redo this, I'm going to have to go back and start from the beginning. Okay? But I'm pretty happy that that is okay. And if it doesn't fit with the other data after all I've done, then I can just throw it out of the fit later. Okay? So, and I could even rename it. I could say 400, and I could say ASP, and I could say bubble. Boobly. That's, isn't that like a musician? Yeah. Okay. All right. So now we've got 2 data sets and 1 blank. Let's see what our next one down is. 400. We go down to 200. And 200 will be at 33.50. By the way, it's putting where you put the flag. And this is why I say always put the flag right before the injection starts, because now we can look for 33.50, and we can know that looking after that is where it will start. Oh, did it not save one? Sometimes you look through and you see that it didn't save one. Because you see we still have something at 2800 there. Oh, I missed it because we had 2 in a row that were both 400ths. Okay, so you can see that here's our second 400 right here. I just skipped by it because I didn't notice that the time was changing, 2771. So, well, that's real easy to get. I'm going to try leaving the bubble on this one in and seeing what it does. So you always want to make sure that you have enough of a baseline at the beginning to be able to line things up. I'm actually going to collect a little more to make sure that we have a good baseline there. Control X, Control V, 0, 0, new color. There we are. And this is the other 400. So this is 400 nanomolar ASP, and this is our 2700 seconds. You probably won't need to put in the time for the later ones, but you can always put in more information if you want to. You never know when it'll be useful. Okay. All right, so now we're going to go back out to the 3346. And there it is right there. And I'm pretty happy that with where it starts and stops that I can just do this. Collect a little bit back, Control X, Control V, 0, 0, new color, and here we are back here. Oh, the only problem is now it's overlapping the other one. So I have to zoom in to find the exact one and double click on it. But there I see that's the dark red one, so that's definitely the one I want. And that was 200 nanomolar ASP. Because there was only one 200 nanomolar ASP, I'm not going to worry about labeling it any more than that. Okay. So the one thing to be sure of, it's easy to open up too many windows, too many project windows that display your data, and always just close it back out if things are getting confusing. You know, opt toward closing it out. Let's, oh, we've got 3 more to do, and then actually, and we've still got another ASP and another ASP there. So I think that we can do a complete set of data if we just go through. I would like to collect another blank. So there's another blank at 4085.6. And by the way, sometimes you might be reading from the wrong number. I've probably done that today without realizing it. But 4085 is going to be a blank. And the blanks are the hardest to find, actually. But let's zoom in right at 4,000. And we don't see much of anything. This is actually can be one of the hardest things to find, is to find your blank there. But once you zoom in enough, you can see 4085. Oh, somewhere around here. Here I see the wash feature. And if I work back from there, Okay, and if I start just a little around where my report flag was, then I can just do this, XV, okay, double click, and this is another blank, blank 3000. All right, let's get two more while we're at it. There's 4553 is 100. So I'm just going to go back to the original window and look for 4553. This is one of the things that was nicer to have the computer do it, you know, but that's life, right? Okay, and once we zoom in, you can start to see the features a little bit better. And you can start to see, yeah, we do have a small baseline rise for our blank. So let's get that all the way through the wash feature, Control X, Control V. And now because it's overlaying on something else, I want to go back to this project window. And it's easier to just double click on it there. And I'm going to say, oh, and this was 100, right? 100 nanomolar asp. Let's do one more for fun. I know, loads of fun, processing data. But you're actually getting something done. Imagine that. 4930. You're putting the universe into order. All right. And so here's our little 4930. Here it is. Here it begins. And here I want to make sure that I have a little bit before the injection. We were cutting it a little bit close. I probably cut a little too much out. And again, that's hard to undo. So one of my options would be to start over again. But I think I have enough to work on it. Control X, Control V. And this is going to be my 50 asp. Okay. Because I want the data to be literally cut out of the previous data. I have the previous data in its original form, and I can always look at that. This is always going to be processed data, so this is not changing the original data in any way. It's actually easier to keep track of where you have cut out if there's a big hole, Swiss cheese hole, right where you've already done it. So it's really to keep track of where I am. If I was better at keeping track of where I was, Control-C would work just as well. Yeah. But because of the zooming feature, it's a little bit clunky, and because you're having to do so much with the data, that's what I've done. These little things, though, you can definitely choose your own way to do things. All right. So the thing is, we have all this data now. This should be a replicate of ASP by itself. In fact, we have two concentrations of 400 to choose from, and we have 2 blanks to choose from. The only one that we had to cut out was the one with the bubble, and you see that was the blue one, number 4, and it tells us what the last action done for that file was. That's actually kind of helpful. So we got to remember that the light blue one was cut and the other one was not. So now I've shift highlighted all of these, and now I'm going to open up a second plot. Now this is our 7th plot window that we've done, okay? But here I can zoom in, and this kind of looks like it might be good data, right? Kind of looks like the shark fin that we need. Now because it was the first thing we did, now the other thing is you'll notice that it doesn't really line up that great with itself. You can see the shark fin is sort of there, and you can see the washes all sort of here, but they don't line up with themselves in the X direction because we were being very approximate in where we start and stop the data. So we need to do 2 things. We need to get the X's lined up, and we need to get the Y's lined up. I like to get the X's lined up first. You can actually do these in either order. Right here is the X transform button and the Y transform button. This is how you line up on the axes. So I'm going to do X transform first, and I'm going to say curve alignment, and I'm going to want to replace original, and I'm going to say next. And now it's given me this little thing where I can look at this, and it's kind of a mess because we do actually have a lot of data here. But what I can do, what I want to do is I want to try to put these all on the exact same point in the curve. Now actually the best point in the curve to use, I'm going to double click to zoom out because I want to include this point. There we are. Okay. I want to try to align it to the top of the shark fin. Sometimes there's a feature, even in the wash, you can align the wash feature, you can align the top of the shark fin, or you can align the beginning of the shark fin. You look at your data and you see what looks like the kind of thing that I can see in all my data. So I can look up here and I can see, okay, great, I have all these data. I may have cut off the top of the shark fin for this one that I cut the bubble out. But you move each of the colored crosshatches to the point where the data ends. Now the one thing that's difficult is I can't see it for this data line. These low data lines, very hard to see. But I can go back and I can just approximate for this one. And then my later ones I can do differently. Okay, so here's this. So let's try to do it for each line. This is another one where I can't really see what's going on, so I'm going to have to go back and do that another time. And slide it along to see which one it goes to. Now the other thing is you shouldn't be aligning on a bubble, but let's see if this will actually line up with everything else. And then finally this green one again. This might be the end of it. This might be the end of the shark fin. We'll see if that works. I've found all my colors. I've tried something to line it up, and now I'm going to say finish. Oh, and I have other plot windows open, but I'm just going to ignore that. Okay, and now I have to zoom in each time. That's one of the annoying things about bubbles. It's definitely looking better lined up now than it was before. I think that the blue one is definitely a lost cause. The purple one is actually has a little bit of a divot in it. It's kind of weird, but it will work for the illustrations purposes. And I think it's good that I can show you what to do with non-perfect data. The other thing that I've probably done, I don't know if I've lined, the green blank looks weird. And so what I want to do is I want to look through these as I do this. I have a green blank and then I have the purple blank. Well, the green blank looks a little weird. You see how it goes up and down a little bit? And I think the green blank was the first one. Sometimes your later blanks will work better. Yeah, the green blank was the first one. I think the other blank is going to work better than this one. The other thing, so I can do another round. I can do another X transform, do curve alignment again, and now it's starting where they were all lined up before. I can pick another feature, or I can try to see where the feature is for this one. So it looks like the brown one, it looks like they're kind of lining up, but I think that it was a mistake to go from that. I'm going to instead try to line up the wash feature. So let's try to go back here and line up the wash feature. Usually you'll have to do one or two tries of this to really get things to line up. The nice thing is the wash feature, if you have a little peak, you can just slide it along and see when it moves up. And you can kind of get it to the maximum there and see how that works. Like this green one is kind of weird. Again, it's our weird blank. And the wash feature is actually usually pretty consistent. Let's see if this works. Now I zoomed in, and if we include the wash feature, you can see that the wash feature is really lining up back here. See, it's all doing the same thing. And the one thing is, oh, these might have been blanks that didn't have enough to them, or I might actually not have selected the whole thing. Whatever's going on, these don't look like they're lining up with everything else. But it looks like our purple blank is really good. It looks like our green blank just had a, actually this is completely accurate. The baseline was just sloping down because it was an early blank. And because of that, the baseline goes way down here, whereas the purple blank is nice and perfectly arranged and flat and things like that. So looking at all these, I think I'm pretty happy with the magenta, the dark blue, and the dark red. And actually, I'm going to throw away all the others. You can usually you want to have 4 or 5 injections lined up, but you can get away with 3. And since I don't want to hold you all ransom here while we're doing all this, let's just get rid of those other ones. All right, so let's try to close the plot windows and try to remember the ones that I want to keep. I want to keep this blank. I want to have the 800. And if you, it's either shift or control click. It's control because it will do that. So we don't want that one. We do want the dark blue one. We do want this one and this one. And it turns out that our higher concentration ones work better, and that's just normally what we'll see. These are actually lower concentrations than most of our other samples, you'll notice. So you'll probably be able to get more than 3 from your own. Okay. Oh, and I'm going to go ahead and close this so it doesn't get confused. All right. So I've shift selected those 4 that I want, and now I've put it into here. I can go back, by the way, and I can open up the blue one, and I can remove that bubble if I want to. Actually, let me show you how to do that, because it's real easy. And it'll mean that I'll have to zoom less. See, I can just select this bubble, and I can control exit out, and there's my shark fin. So that bubble really was just getting in the way. It wasn't doing anything. Now I'm going to shift select again. Not shift select, control select. Those are my 4 pieces of good data. Now I'm going to click my overlay button. And now that they're overlaid, by the way, I can cut out this, control X. And now I don't have to zoom as much anymore because I've cut out all the non-zoomable data. Okay. Now the one other thing that's still weird with this data is this little blip right here. This is about the limit. I can still use this data, but it'd be nice to have another injection, and we do have other injections, but I'm just going to show you what this one looks like. You want to, now we've got our data lined up in the X direction. It's starting here and it's stopping there. Now we want to line it up, and we want to find the X baseline because it's not lined up in the Y direction yet. So now what I'll do is I'm going to do the next one over. I'm going to do the Y transform. But before I do the Y transform, I want to actually right-click select again. Remember that right-clicking is going to be selecting. And I want to select the real narrow band. It might have helped to zoom in a little bit, but I was able to just barely zoom in. I was able to get my part selected. I want this to be my flat baseline before the injections start. And like I said, yours will probably look a little simpler than this. But now I click on the Y transform button, the one with the up and down arrow, and I say 0 at average of selection, and replace original, and apply to entire working set. I want it to average these values and make them all 0 and pull all the other curves after that. And see, that's exactly what it just did. And now I have what looks like a pretty good lineup. You know, if I have more time, I might want to do another X transform. You can keep doing those X transforms, you know, until you have it lined up perfectly. Or you can try something. If your fit is doing something weird to you and you want to try another X transform and refit, often that has helped the fit work better for me. But we've got our X transform, we've got our Y transform. I'm going to go ahead and call it a day and want to say I want to turn this into a KD. Now what we've done is we've run a reaction at 4 different concentrations, technically 3 because we have our blank. We're going to sort of subtract that out. We have 3 different concentrations of our ASP that we've put over, and we've gotten a different response from each. We want to see how high each of these goes up when it gets close to equilibrium. So equilibrium is going to be the flattest part of the curve. Remember, equilibrium, at first you're going to be changing quickly, and that's going to be when you're measuring kinetics, but then the system's going to slow down. It's still binding and unbinding, but it's binding and unbinding at the same rate. You don't see the system changing anymore. And so this part of the curve is closer to equilibrium than that part of the curve. And that's what you're going to measure for lab 3. All right. So there's one more Y transform that you need to do. You do this Y transform without selecting anything because you want to subtract your blank. And you see you go down here, blank run subtraction, and you just say I want to subtract blank 3000 from everything. So you say replace original, And you know it worked because the blank was subtracted from itself and it just became a big flat line of zeros. Now I can go back, I can close this window and I can reselect the non-blank lines and reopen it. But there's another little trick I can do with that. I don't have to close the window, do the same thing. If I go to Edit Working Set, that shows me the curves that are in my working set, these 4 curves. I just subtracted out my blank, so I don't want it in my working set anymore. You click on it, click Remove, and then say OK, and no more blank. Okay. Now we're finally ready to turn this into a KD. What you do is you use this, you use the Fit General button, the last button up here, because what we're going to be doing is we're going to be we want the response at equilibrium. So the first thing it does, and it's really terrible at predicting what you want, so you just have to sort of tell it. What you want to do is you want to select the area as close as possible to the end of the shark fin without going over into it. These should be mostly flat lines, and in fact, you see how it's curving? Just a little much for my taste. A little bit of curve is okay, but you want to minimize the curve. You want to get it as flat as possible, so I cut off that end to get this little stretch, and we have 3 levels that are sort of flat-ish, okay? Those are my areas where it's closest to equilibrium. And so I say, after I've selected that, and notice how I selected it with the gray bar. The gray bar tells me what is the selected area of data. Okay? So I want to, here's where I want to know the average of each of those areas. This is where, number 1, you've imported the average model. If you don't have this option, that means that importing didn't go right, and so you want to go back and import it. But here he wants to know the concentration. This is why you labeled all those previous ones before, because they're each labeled. You can just put in 800N, 400N, and 200N. You will be putting in very similar numbers to this. N basically just means 10 to the minus 9th. It's telling you as a calculator, multiply that value times 10 to the minus 9th. It's a lot easier than typing in that little caret thing and trying to tell the computer how to do exponentials. Okay, so we've entered in all these. It thinks a little bit, and it fits each of them to a flat black line. That's the average at each of those points. If I go down here, there's a parameters tab. And if I look at this, oh, right here, it's saying that I have this response. I inject this concentration, I get this response. And it actually gives you the error for that response, the standard error for determining that response. Those standard errors are pretty small, and as concentration goes up, response goes up. Good, I should be able to use this. To turn this into a graph, you go Fit Plot Parameters, and you want to make this into a graph of concentration versus REQ. So you select conc for your X value, REQ for your Y value, and you say OK. And then, believe it or not, you have a hyperbola. This little dot is, so here's your concentration, and here's your response. It doesn't go all the way to 0, but this is basically, it goes up when you inject more protein. Now, hopefully, the one thing that might go weird, and it might have gone weird for this particular one, it might not be going up in a hyperbola. We'll see what it does. But it's going to try to fit this to a hyperbola. Now, from 3 data points, is it a hyperbola or is it a straight line? We don't know. That's why I want you to get 4 to 5 data points for each replicate. But again, 3 replicates of 4 data points each will be okay. And you can even get by with a 3 data point replicate like this if it goes together with the other data that you fit it with. Don't let me, and your job basically is to just do the fit the best you can and give me some numbers and some graphs. You know, and I can go and fit them back in together myself later. Okay, so to fit this to a line, you do general fit again. Make sure at this point that you expand the data selection bar at the top so that it includes all the data. At first, it did not include the most important data point there. But really, you're fitting 3 data points. Before, you were fitting like hundreds of data points and averaging them. Now you're fitting 3 data points to a hyperbola. And you change this fit to steady state affinity, n equals 1. And there it did its best to fit. So the one thing that we can look at is we got a equilibrium constant. We got a Ka, a Kd. It says the maximum response. This is where the hyperbola is headed towards. And right now the maximum response is over 100 times. This probably is not the best fit, so I'm going to want to go back. I'm going to take this data and I'm going to see if I can get a better fit or if I can fit in those other ones. Just getting 1 or 2 more data points down at the very bottom is usually a huge help to this. But the other thing to realize is that the 0 should be part of this graph, and it's not. So when you're looking at it and evaluating it, be sure that you think about things that way. Okay. But the other thing that we can look at, so it gives you the Ka and the Kd. The Kd is just a reciprocal of the Ka. And so you can see it's finding about a 15 micromolar interaction between these two things. So I go to parameters right here, and I can actually get an error for this. So these are the values that I'm going to want you to copy down. Copy these into a spreadsheet, and this is what the lab is asking for. Okay. Now in this case, can you tell me one issue I might have with my standard error? The standard error is times 10 to the 5th. The Ka itself is times 10 to the 4th. Kds are a little bit weird to deal with because they're reciprocals and they're negative logs, But Kas are actually simpler to look at, and you can see that my error is bigger than my value. Okay, so we have to go back, and maybe I can find a way to fit in the other ones. Maybe I can make this replicate work. But at the end of the day, it's close to working, and you might have a few cases where your replicates just don't come together. I mean, try stuff. Let me know what you see. My judgment from looking at things is I think that we've all got good enough data, and this is when we were just trying stuff, This is everybody's first injection on this. So I want you to do graphs like this, except I would like them to have 3 to 5 data points, hopefully 4 to 5 in each case. But you can see there's some other things you can click on. But the important thing is once you get to this, you've got your numbers. If your standard error is like 10 to 20% of your Ka, then you've got a good fit. And this is the other way around, right? So this is not a good fit, but I will spare you the details of going back and forth, reselecting stuff. Maybe that cutting out that bubble didn't work. It looked like the bubble one was sort of not fitting with the other ones. And you should see it go up in a sort of hyperbolic pattern. In other words, as you double the concentration, you should see it go up, but go up less than double each time. So you should see it getting closer. And it looks like our middle point, like that 400 point right there, does not follow that pattern. In fact, it looks like it's going up more when we go to the higher concentration than it should. So that's just a sign that's something that we can change. Now, the one other important thing to do, once you have a fit, don't close it because then you'll lose it, okay? Minimize it and keep it right there. In fact, if in doubt, minimize stuff and keep it around just in case, because then we can reconstruct what you did. And then save the file. It will save it as a BLE file, which is BIAcore Evaluation. BLR files are the raw data files that are opened up by the control software. But I am not going to save this because I want to go back and work on it later. All right. That is